Already. Already? Okay, says the boy who hasn't been here all week. All right, let's start with the non-calculator. Y'all want to start with calculator or non-calculator? Calculator? I forgot my calculator. But that's okay. I mean, I can still talk you through it. Y'all did better on the calculator part this time than last time. Yeah, you did.
Yeah,
Start with non-calculator. All right, part A. Part A. I should have probably. You want me to read you the answers so you can mark them? All right. Let's see. Hold on, Coach Beck. Did y'all go ask Coach Beckley? Because he's asking. What room is this? Major Wallace's.
just say somewhere directly under himself.
Well, one over. That one's directly under us.
Well, they'll figure it out.
So directly under Chang. Oh, he tried to call me too.
Yeah, he said that earlier.
Robert, he's got junior leadership. They do. Did y'all have it that much? It feels like it's a lot. All right, y'all ready? Number 1 is D, 2 is B, 3 is C, 4 is B, 5 is A, 6 is B, 7 is D, 8 is A, 9 is D, 10 is A, 11 is A, 12 is D, 13 is D, 14 is B, 15 is C, 16 is A, 17 is A, 18 is D, 19 is C, 20 is C, 21 is A, 22 is B, 23 is A, 24 is C, 25 is D, 26 is C, 27 is C, 28 is B, 29 is A, and 30 is B. Wasn't as many A's as last time. And that's what Lauren said too, because there were so many A's last time. She just went through and guessed A for everything. All right, starting with 76. 76 is D, 77 is B, 78 is C, 79 is B, 80 is A, 81 is D, 82 is D, 83 is C, 84 is D, 85 is B, 86 is C, 87 is B, 88 is C, 89 is A, and 90 is C. There were 2 A's in that whole section. All right, with that said, let's move on. Do y'all have questions? Let's see. Number 1 was just a straight derivative with a chain rule. Do y'all need, stop me if you need me to work any that I'm kind of skimming over. I don't mind at all. 2, I'm assuming some of you need number 2. Or number 1? 2? So I started doing a U sub on number 2. Realized that my answer didn't quite look like theirs with the U sub, and I saw the 1/3 and the 3's. I knew there was something with that, so I factored out a 3 before I started, and then I put that on the outside of the integral, so that then whenever I did the U sub, it was x plus 4, which means du was just 1. So I got the 1/3 the log of, which is absolute value. Let's see. Which was B. Let's see. Questions about that one? Yeah, okay. 3 was quotient rule. Pretty straightforward. It was C. Anybody need it? I don't want to get bogged down in the ones that, because last time we didn't get to quite everything. 4 was the trap rule. I didn't do an analysis on what y'all missed the most, but I'm gonna assume somebody needs this one. Did y'all get it? It was trap rule, no calculator. So I went through, of course, I did my width on each one. This was 1.5, this was 1. And then I went through and set up my trap roll. So 1/2, I can't do the height, the width on each one outside of it because they're all different here. So I had to do each trapezoid on its own. So first one was 1/2 times 20 plus 60 plus 1.5, 60 plus 40. This one you could get bogged down in because you don't have a calculator, right? Half of 80 is 40. 100, 1.5 times 100 is 150. Are y'all with me or no? And then 70. And from there, I just got 130. Remember, you don't have to show any more work than what you want to show on these because it's multiple choice. 5. 5 was pretty straightforward, but you had to chain it there, and there were lots of 2's in that. So if you get confused, I'm going to assume that's probably where things went awry. So if f of x is sine x squared plus pi, so I found the derivative first. So remember, for that, I'm doing trig, which would be the cosine. Everything stays the same, and then I chain it. But what you're plugging in here is that square root of pi. So I got square root of 2 pi, and I got square root of 2 pi. Well, square root of 2 pi squared just gives me 2 pi, and 2 pi plus pi is 3 pi. And I'm multiplying that by 2 times the square root of 2 pi. So lots of 2's there. Cosine of 3 pi, I've just looped around. Here's 1 pi, 2 pi, 3 pi. So I'm back here at -1. That confused you? Which part confused you? Yes, no, Moses? Well, no, go ahead.
Oh, no, I have 3 pi too. What is it?
Because when you plug in square root of 2 pi, you're squaring that right there, and the squares cancel out. So you end up with 2 pi plus pi.
Okay, but what I did, when I got here, I did cosine 3 pi, which would be negative. So why would it not be negative?
It is, which is
How is
A.
it not A?
It
Oh, wait,
is
I got it right.
A.
I thought it was A.
No, that's okay. All right, 6. 6 just asks for average rate of change. These, I feel like the biggest problem here on these are careless mistakes, because really all you're doing is plugging in. You're finding f of 1, you're finding f of 5. I got 2 and I got -50. And then you're doing the slope between them, which would give you -13. You need me to work that one? All right. All right. Make sure y'all stop me if you need me to work it. For 7 was just testing your knowledge of what you can do with those integrals. So this was you had all you had to do is add them together, because it's asking you for the integral what, from -10 to 6. They gave me from 4 to -10, but the problem with that is I needed to go from -10 to 4, right? This one was -3, so I dropped the negative sign and took it from -10 to 4 and made that 3. And then the other one is from 4 to 6, and it was what, 5? And then you can just add them together, because added together it would be from -10 to 6. It would be 8, which is D. If you missed any so far, it's probably a careless mistake if I had to guess, because so far we've been pretty straightforward. 8, we start getting into what I thought was a little bit harder. F is the function given by f of x equals e to the x over 3. Which of the following is an equation to the line tangent to the graph at the point, and then I've got this nasty looking point, 3 log 4. So first thing you need for a tan line is the slope, and for the slope I need the derivative. So I found the derivative here, so e to the x is just e to the x, but I have to chain it. So don't forget the chain. What's the chain of that one? Y'all can do this. 1 over 3, because x over 3 is the same thing as 1/3 x. So e to the x over 3 is my derivative, but I need to evaluate that at 3 log 4. So e to the 3 log 4 divided by 3, those cancel. And e to the log 4 is just 4. So I end up with 4 over 3 for my slope. And then there's my point. So y minus y1 equals slope, x minus x1. So it wasn't quite as hard as it looked, so that's A. They didn't even solve it for y. They left it in point slope. What the hell? Part 9, or number 9. I always get so confused on these because they always mix up what they're asking you and what they're looking for. So this was the function itself. Not the derivative. So I'm looking at the integral of the function, which means I'm looking at the area under the curve. So you've got this nice little curve, right, that does this. So I literally did, this is what I wrote on mine because I couldn't wrap my brain around what I needed to do here. I wrote big, and then from 0 to 3, I wrote medium, and then I wrote little here so I'd remember. And that's what I wrote above each interval. So you remembered which one was the big. So I'm looking at positive and negative and what happens there. So it's D. D starts out, it goes from smallest to greatest. I think y'all did pretty well on that one. Better than me.
Will that count as a negative though? I got it right first.
Yes, because it doesn't ask you for area. Integral can be negative, but area cannot. Yeah. All right. Number 10. Anybody need number 10? I mean, it was a U sub. Yeah. Okay. All right. From 0 to 2, x to the third plus 1 to the 1/2 x squared. Because the one out here was 1 degree less than the inside, I figured I would probably need to let u be the x cubed plus 1, which means du is 2x squared. So I need to counter that out here with a 1/2. Go with me? 3. What I wrote, so I guess not looking at what I did. Okay, so 1/3 outside, so I've got 1/3 times the integral from 0 to 2, u to the 1/2 du. And now it's just an antiderivative, but I am going to have to adjust those bounds. If you didn't adjust the bounds, that answer's on there actually. That kind of sucks. But all right, so I got 1/3. I'm going to go u, actually 2/3 u to the 3 over 2. And I'm going to adjust these bounds. 0 becomes 1, 2 becomes 9. I multiplied these together and got 2 over 9, and then I did 9 to the 3 over 2 minus 1 to the 3 over 2. 2 over 9 times square root of 9 is 3. 3 cubed is 27 minus 1, which is 26. 26 doubled would give me 52 over 9, which is A. Sometimes you get bogged down in that math because you think there's no way they're asking me to do all this on a non-calculator, but they do sometimes. How about 11? Yes, no, maybe so. You don't need it, Brian? I'm glad you don't need it. I'm going to do it anyway because I feel like some of you might need this. It says at the point 2, 1, so this is the one where I'm taking the derivative, but I have to do it with respect to y whenever I take the derivative of y. So I'm going to go 2x, and then I've got a product rule here, derivative of the first times the second, plus the first, am I going too fast? For the second, dy dx, minus 3, I need another dy dx because I took the derivative of y equals 0. It's not distracting at all. That's a she. I'm going to solve it for dy dx. I actually plugged in before I solved for dy dx. It really doesn't matter. You just need to get dy dx by itself, and that's your answer. I just went ahead because it was easier for me to do this. 2 dy dx, but it doesn't matter. Minus 3 dy dx equals 0. That was 3. I moved that to the other side, combine like terms, so I got negative dy dx equals 3. Is that right? No. 5. 2 times 2 is 4. So dy dx is 5, which is A. Number 12, the number of gallons of, I feel like this is so boring right now. This is not so. I don't know. I guess it's not. It's so monotonous and boring. The number of gallons of water in a storage tank at time t in minutes is modeled by, and I've got this equation. That's giving me the number of gallons. If t is in minutes, and if I take a rate of that, which is a rate is derivative, anytime you see rate, you think derivative, that gives me my gallons per minute. So all this was asking you for was the derivative at 3. It was a pretty easy derivative, 25 minus t squared. Derivative would be negative 2t, which would be negative 2 times 3, which is negative 2. Pretty straightforward on that one. I way overthought that one because I was like, there's no way it's that easy. 13 was a struggle for me. I probably spent longer on 13 than on a lot of them. So in looking at 13, if you look at that slope field, the thing that I noticed first, I always try to find a pattern. Are all the x's the same across, or are the y's the same up and down? And I noticed that if you look across for a certain y value, like when the y value is one particular thing, then all the slopes are the same. In other words, when y is 2, all the slopes are the same. When y is 4, all the slopes are the same. So that was my first note that I looked. So I started when y was 0 and how that might impact, which didn't really. What did I do? I'm trying to think. I want you to know my thought process. I try to make notes. I remember what to tell you that I was thinking as I went through this one. When y equals 1, they all have the same slope. So I knew that. And then I started plugging in points to see what happened. I automatically eliminated A and C because when x was 0, that would have given me 0, and that's not always the case. So I eliminated A and C right off the bat, and I was down to B and D. So I knew if I was short on time, I could at least get a 50-50 shot on that one. And then I started plugging in points. I plugged in 0, 1 to both B and D. I got the same thing. I plugged in 0, 5, and what I noticed at 0, 5, for B, I got negative 5/4. And for D, when I plugged in 0, 5, I got negative 25/4. And so what I did was I looked on the graph to kind of see that this one should be steeper than this one, right? Because 25/4 is bigger than 5/4. So past 4 on here, when my y gets past 4, my lines start, you see as you go up, the lines just start getting steeper and steeper as y gets bigger. And so that's kind of what I thought. And so that's why I went with D, because D had the steeper slope. That's what I was looking at. That one was tough, though. I feel like some of those are really tough to figure out. But again, if you can get some of them eliminated and then make a best guess between two if you're short on time, that's probably the easiest thing. If I was running short on time, remember 2 minutes per question. If I'm behind on time, I'm marking those two out. I'm guessing, bubbling in, starring it, and coming back to that one. 14 was also not incredibly easy. It wasn't terrible, but there was a lot of work, I felt like, with number 14. The weight of a population of yeast is given by a differentiable function y, where y of t is measured in grams, t is measured in days. The weight of the yeast population increases, so I've got this differential equation. But it says that k is a constant. At time 0, so here's my initial condition, and so I automatically thought I'm solving a differential equation because they gave me a differential equation and they gave me an initial condition. At time 0, the weight of the yeast population is 120 and is increasing at the rate of, so dy dt when t equals 0 is 4 grams per day. Which of the following is a good expression? So, did anybody get this one? This one was tough. All right, so I took this equation first and I went ahead and separated out my variables, okay? So I got dt on this side, I got y on this side. So I got dy over y. This is a constant, dt. And then I took the integral of both sides. So I got the log of y equals kt plus c. Then I took that initial value, right? That initial value of 0, 120. So the log of 120 equals k times 0 plus c, and I found my c. So right now my equation is log of y equals kt plus log 120. Then I solved it for y, so I e both sides. So now I have y equals e to the kt. And remember, if I'm adding these exponents, that's like saying times e to the log 120, which cancels and just becomes 120. Right? But I'm still not solved for k. And so what I did at this point was I plugged that initial condition in again to find out what k would be. There was probably a much easier way to work this than what I did, but this was what made sense to me. What was my point against 0, 120? So 120 equals 120 e to the, is that what I did? Oh, no, I didn't. 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 Don't do that. Don't do that. That's silly. Silly. I went back because I used that other piece of information that they give me. They said dy dx or dy dt is 24. So I used that. Where's that equation? Dy dt equals ky, and I plugged that in. So 24 equals k times 120, because y was 120 at 0. This one was hard. And there's my k. So it had to be b. Because if I put 1/5 in for k here. I had a lot of work for this one. I spent a long time on this one also. Again, if I was crunched for time, I probably would have starred this one and came back to this one, because this was a pretty involved one. For 15, I eliminated A and B right off the bat, because as I look at the graphs of F and G, I know that it says which one of the statements is false. Well, I know that the limit as x goes to 1 on f is 0. Just because there's a discontinuity like that, yeah, they throw you on that. So f does have a limit at 1. Just because the function's defined at a different point doesn't mean that it doesn't have a limit. B is true because the limit as x approaches 2 does not exist. That's true because I've got a jump discontinuity there. So then I was down to C and D. It says that the limit as x goes to 1 of these things does not exist, and then, or it does exist. So why did I choose g of x plus 1? I looked at D and I said, for D, I knew that it did exist. I knew that was true because even if you look at f of x plus 1, everywhere, the limit always exists everywhere on here. This was one that I just used the best possible answer. For C, I couldn't say for sure whether or not this g of x plus 1 existed or not because I don't know where they are on here. But for D, I could definitely say everywhere on F for this domain the limit existed. So that's why I eliminated D and went with D. That was my thought process. I thought that one was kind of tricky. All right, 16. F be the function defined by bleh. All right, so I did a sign analysis here. This was just a double derivative. They want to know concave up and increase. So I did first derivative, and I stacked my sign analysis on top of each other here. So I got 12x minus 6x squared. Found the zeros here. I got x equals 0, x equals 2. And then for my second derivative, 12 minus 12x, x equals 1. And so I did a double stack on them. I did the first derivative, 0 and 2. And I got negative, positive, negative. And then I did the second derivative right under here at 1, which falls halfway in between, and I was positive, negative. And so if I'm looking for concave up and increasing, I'm here between 0 and 1, which is A. How about 17? How'd we do? What's wrong, Avery? You just did the increasing part? Oh, I hate first times like this, especially whenever I'm talking about a trig function because I've got to think about that unit circle and going around, and when something happens for the first time, it gets quite aggravating. But anyway, when's the first time the velocity of the particle is 0? So I first have to find velocity. I'm assuming most of you did that to start with anyway. I pulled a 12 out. Then I did derivative of the first, chain it, times the second, plus the first, times derivative of the second. I did change it just a little bit. I did subtraction, and I actually factored out e to the, since I knew I was going to have to set it equal to 0, I went ahead and factored out an e to the negative t. And I have cosine t minus sine t. I need to know when that first equals 0. Well, this is never going to be 0, right? There's nothing I can raise e2 to give me 0, so that doesn't even impact my solution. But this one, If I separate those a little bit, be careful that corn. When's the first time sine equals cosine on the unit circle? Y'all can do this. When's the first time that those two coordinates are the same? You move around. Y'all, what is wrong with y'all this morning? As I go around with pi over 4. Pi over 4 is the first time that happens. That's that root 2 over 2, root 2 over 2. They have the same value. That's the first time they have the same value, so it's pi over 4. So it says, when's the first time this happens? Well, when's the first time that they equal? Brian, you hanging in down there? All right, 18. Was just that fundamental theorem. If you look, it's saying what's the derivative of that. It's just replacing the t with x's. It's d. They ask you for the derivative of an integral, they're just canceling each other out using that variable up top, so it's d. Remember though, if that up top happened to be 2x, then you'd plug in the x, but then you'd chain it and you'd multiply everybody by 2 in the end too. Y'all remember doing that? I figured it looks. You okay? Looks like you're fixing to fall asleep. 19, let f be a function, f of x equals what's approximation for f of 1.5 using the line tangent? So we had to find a tangent line first. So I found the derivative. And then I found that at the point pi over 2. Sine of pi over 2 up top is 1. So this is -2, so my slope is -2. Then I plug in to find that point. So f of pi over 2 would be 2 cosine pi over 2 plus 1, which would be 1. So y minus 1 equals slope times x minus pi over 2. And then they want you to plug in 1.5. Yeah. So y minus 1 equals -2 times 1.5 minus pi over 2, which looks like, what am I going to do? But 1.5 is 3 over 2. So I have y minus 1 equals -2 times 3 minus pi over 2. Just cancel. I'm going to move that 1 over here. So I get, the negative is going to stay though. -3 plus pi plus 1. -2 plus pi, which is c. It looked like it was going to be so much worse than what it turned out to be. The slope. Just you had to go back to the original function and find the point. The point and a slope. And then plug 1.5 into equation. Oh. 18 just cancels because it's asking you for the derivative of the integral. And that's that one where we just replace the p's with the x's. The only thing is, if you end up with something like 2x up top, if you go from like 5 to 2x or whatever it is, then you would take that, whatever that equation is, tangent 5x secant 5x minus 1, and then you'd have to multiply by the chain. But anytime you're asked to find the derivative of the integral, they're just canceling each other out. Which of the following is true? Again, without a calculator. The limit as x approaches 2 of f of x equals 1/2. I plugged a half into here, and I got negative a half, and so I knew that it wasn't a. For part B, removable discontinuity, this was one I literally eliminated choices to find the right one. Removable discontinuity at x equals 2, I know it's not removable because there's not a hole there. It's, I'm thinking it's a corner or a cut because of the absolute value. C, I wasn't sure about because I don't know what's going on at 2, but I did know that it wasn't a vertical asymptote because the bottom's not, it's not a polynomial whose bottom's going to 0 like that, so I knew that there wasn't a vertical asymptote, which left me with C, and I really didn't have a whole lot of algebraic justification for that other than I eliminated A, B, and D, and it just left me with C. '21 was the alternate definition. That's about as, remember I told you they might throw one in there, but, and that's about all you'd have to do with it is just recognize. This is like the limit as h goes to 0, but it's the other way. They just recently started testing this within the past like 5 or 6 years. I think. I don't know. We never used to push that. But anyway, that's the alternate definition, which just means if you can pick out your function, well, it told you that the function was f of x. So if you could recognize that being the derivative at 3, you would know that it's 1/3. And chances are, if they give you a function with a limit equation like that, you're looking at a derivative. So it's 1/3. Do you see now? No. If you ever see, because this is not, right. And it's just that, you know, we got that difference quotient, the limit as h goes to 0, blah, blah, blah. This is the alternate of that you could use. And it's just, it is the definition of the derivative. So if f of x is my function, then this is asking me for the derivative at 3. If you ever see f of x defined followed by a limit like this, you're finding the derivative of f of x. Let's see. 22 was a doozy. Did y'all get 22? We're right on time. We're 22. We've been in. Okay. You guessed it right. It was B. Did you have a reason for your guess? It was a blind guess. You had to do separation of variables on this one. It had an initial condition given. So y is greater than negative 1/2. I'm going to split these up so I get dy over 2x equals 1 over 2x plus 1. I actually, whenever I did this one, I must have not seen my answer popping up. I left the 2 over here when I did this. This should be a y minus. And then we're off. So the natural log of y equals 2 times the integral of 1 over 2x plus 1. I did a little simple u sub here. I mean, if you can see it without doing the u sub, then that's fine. But this is why I went back and erased and changed how I did it. Because this is 2, I need to counter it with a 1/2, right? Which is just going to cancel that out. So I got the log of y equals the log of 2x plus 1. Plugged in that initial condition of 0y, or 0e. So the log of e equals the log of 2 times 0 plus 1. Of course, I highly doubt that you're going to be doing all of this work because this is multiple choice, but 0 plus 1 is 1. The log of 1 is 0, so I just get 1 as 2. So now my equation is the log of y equals the log of 2x plus 1 plus. And I'm ready to solve it. So e both sides, I got y equals 2x plus 1. And I'm multiplying that by e to the first. Because remember that adding up here means that I multiply with the same base. That is so obnoxious. And now it looks like b if I distribute that e through. E times 2x plus. That's okay. I e'd both sides. And to get here, this is like saying e to the 2x plus 1 times e to the first, because you add exponents when you multiply with the same base. Once I got to this point, I kind of looked at the answer choices to see how they were written, to see how I needed to kind of rework my. I messed up on 23. I did end up going back and getting it, but I have a lot of eraser mark on this because I didn't read it all the way. It says that the cross section is perpendicular to the y-axis, which means each of my equations need to be with respect to y, not respect to x. I did sketch a graph. X squared looks like this. 2x looks like this. So 2x is on top. But I do need it solved for x instead of y. Did y'all get this one? What's wrong? Is she still nailing that same thing? Who is it? It says a rectangle whose height is 3 times its base in the plane. So what I did was I came over here and I said, okay, well, let me do the base first. The base is spanning here, right? So it's right minus left. So square root of y minus 1/2 y. That is so obnoxious. So the height is 3 times that. And the area of a rectangle is just multiply together, right? So 3 times square root of y minus 1/2 y times square root of y minus 1/2 y. I stopped here to see if this looked like any of my answers and my answer choices. And I automatically eliminated C and D because whenever I saw that it was with respect to y, I know that C and D can't be right, so it's either A or B. I know that I'm subtracting in there, so it's got to be A. If you knew which one was on top and which one was to the right and which one was to the left, you didn't even really have to do all that. You could have looked at the answer choices the way they were. I know it's got to be with respect to y, so that's A or B. And if I've got a little sketch over here, I know it's the right minus the left, and you could have gotten to B on that. I mean, gotten to A on that one without doing a whole lot of work. It said the height is 3 times its base. No, that's okay. I love problems like 24, but I think it's the algebra teacher in me that loves problems like 24. Average value of a continuous function on -2, 4 is 12. So what that means is if I'm from -2, remember what average value means, right? Average value means 1 over b minus a times the integral from a to b of the function, and it says it equals 12. And then it came over here and it said from -2 to 4 of f of x, what is it? Over 8. So I know that 1 over 8 times the integral from -2 to 4 of f of x is what I'm looking for, right? So if I can find this, then I could figure it out. Well, I have that over here, right? 1 over 4 minus -2 is 1 over 6. So I can solve that for the integral itself, multiply both sides by 6, and I get 72. So all I have to do is divide by 8, which gives me 9. Let's see. Do I need to go nail it in for her? She's got to be nailing multiple things. This is giving Harry Potter vibes. Like whenever, what's the girl's name? What's the lady's name in pink? Umbridge is nailing all those things on the wall. All those. Okay. Just welcome. All right, 25. The figure above should, yep. 9. I'm fixing to have to go ask her kindly if she could please do that number 9.
I did that way different than you did it. I think I just did it wrong.
No, did you get 9?
Yes.
Well, you might not have done it wrong. What'd you do? I could have done it way.
So I did.
I always jump to algebraic if I
I
can.
did 4 times 12, 48 divided by 8. And then I did.
Where did you get the function that you were plugging into whenever you said?
Well, it said with the average value, so. I mean, it worked.
It worked, yeah. Okay. It worked. We don't care on multiple choice. We just want it to work. All right, 25. 25, I've got to do a product rule. I want the derivative. So derivative of the first times the second plus the first times derivative of the second. And it says at 2. So I started getting confused. I wrote what the slope was of each of these lines above it. And so I've got f prime of x is 1/2 because it's a constant. It doesn't matter what value it is. It's going to be a half because it's a constant slope. Same thing with g. So g prime was -2. It made it a lot easier as I filled things in up here. So f prime of 2 is a half. G of 2. So if I go to 2 on here and I find where's that point, I got 1 plus f of 2, same thing, look at the graph, you get 3, and g prime would be -2. And that would give you -11 over. Did I get that one? Good. $26. I L'Hopital 26. Did y'all L'Hopital it? You don't like limits? Nobody likes limits. It's going to infinity. I didn't, honestly, at this point, I was running short on time. And I was like, you know what? I know the bottom's going to infinity. I'm going to assume the top's probably going to infinity. I'm just going to jump straight to L'Hopital. I didn't check to make sure. I probably should have. But so I just went ahead and I said the derivative of the top would be 1 over e to the 3x plus x. Now I got to chain it. E to the 3x times 3 plus 1. And derivative of the bottom is just 1, so it doesn't matter. Well, at this point, I just got, oh, this should be, oh, this, what did I cancel? I said essentially this cancels for some reason, and it left me with the times 3. I don't know what I did. Great day, what did I do? Derivative of the top times, and then chain it, e to the 3x times 3 plus 1. 3e to the 3x over. Is this what y'all did? For some reason or another, I pulled the 3 off here. E to the 3x. Yeah. And it's 3. I'm going to have to go back and rework that one. I worked it wrong. I got the right answer working it the wrong way. That's a mistake. I'll go back and look at that one. I don't want to waste a whole bunch of time because I do want to get the calculator today. 27, the graph of the derivative. Here we go. I did sign analysis on this one again. I love a sign analysis. I go through and check each individual thing, and then I look at the answer choices. So first thing talks about continuity. Is the function itself continuous? Well, if the derivative is continuous like this, then the function itself has to be continuous. If I'm differentiable, then I'm definitely continuous because that's the definition. So number 1 has to be true. Number 2 asked me, is f decreasing on the interval? Well, I did a little sign analysis and said, okay, if the derivative is positive, I'm increasing. If it's negative, I'm not. I don't know what this point is, but I see that I'm positive and then I'm negative, which means I'm increasing and decreasing. So am I always decreasing? No, I'm not always decreasing. So 2 cannot be true. And then 3 said that the graph is concave down. So if you think about the second derivative, which is the slope here, the slope is always negative. This is always decreasing, which means I'm always concave down. So it had to be 1 and 3, which was C. Holy crap, number 28. I did it, and it took a lot of work, and it took a long time. Let me just run through quickly so you see how to do it. This was a related rates problem. And this was, at this point, you're probably out of time, and you're probably going, what the heck? And you're guessing at this point. You chances are you're not getting through everything in time anyway. If you have time, come back and work it, but I'll show you. It says that the isosceles triangle has legs S, area is 1/2 S squared. The instant when S is the square root of 32, the area of the triangle, so the ADT, when S is the square root of 30, I have to write all this or I lose track of what it is they're asking me and how I'm going to do it. It's 12 centimeters. I don't even really worry about units whenever I'm on multiple choice because I'm just trying to get through the problem. At what rate is the length of the hypotenuse of the triangle increasing at that instant? So I have a little triangle over here that I drew. This is S, this is S. I called this H. So I need DHD. I'm using area. The problem is, if I do area the way it is, if I take the derivative of area this way, I end up with a ds dt and an s in there. I don't know ds dt. So what I did was I wrote h in terms of, or I wrote s in terms of h, so that I only have h's over here. Because that's what I need is the dt. So I said s squared plus s squared, squared. 2s squared is a squared. So h is the square root of 2s squared. Right? No, I'm solving for s, not for h. Sorry. Divide by 2. And now take the square. That's why you, which is h over square root of 2. Now I did all that because when I do this area, right, I have DADT, I need DHDT. So I need to write it with A's and H's, no S's. So now I can say, well, that means that the area is 1/2 times not S, but H over the square root of 2 squared. Keep moving. That means DADT, 1/4 2H DHDT. And you can plug in what you know here. I know that, what did it give me? It gave me S is the square root of 32. If S is the square root of 32, then I can figure out, didn't it say when? I had this 1/2 outside. Didn't it say the area was? I can't focus. I can't think. Well, I'm guessing that 90% of you, there was no chance. Not that you couldn't do it, but the time that this would take, you would have had to have saved so much time on your other questions to be able to get through this one. All right, same with us because it's already 10 after 9. All right, so when you plug in here, you'll come back to your DADT or your DHDT that you need when you plug in what you have. All right, let's keep moving. 29. Which of the following has exactly one horizontal asymptote, no vertical asymptotes? And so as I look at this one, I noticed they're rational, or most of them are rational. First thing I looked for was vertical asymptotes when the bottom equals 0. And I eliminated B and C right off the bat because B has a vertical asymptote at -1. And C, I don't know what the vertical asymptote is, but I know the bottom equals 0 somewhere, so I automatically eliminated those because they did have vertical asymptotes. Exactly one, this was another one where I'm running out of time, so I'm just doing what I know. One horizontal asymptote, well, I know if it's a rational and it's bottom heavy, y equals 0 is the only asymptote, and so I looked at A and went, wait, that one's bottom heavy. I don't even have to look at B anymore because A's got to be the answer. Does that make sense? Bottom heavy, y equals 0, so that's 1, and then no vertical asymptotes there. So I could definitely get that from just glancing. So it's A. What? C is bottom heavy, but it does have a vertical asymptote because x cubed plus 1. Yeah. All right, number 30. 30 is the only one I missed on here. The only one I missed on the non-calculator. I made it harder than what it was, and I said it. But anyway, the right Riemann sum with n sub, and it gives you this equation, and it says what's the value of from 0 to 2. Well, they gave you this equation. So what you're doing, if you think about what a Riemann sum is, a Riemann sum takes an infinite number of, or you want it to be an infinite number of subintervals, right? So we want n to be as big as possible. So what you do for a Riemann sum here, if I take this, again, y'all hate limits, but this was a limit problem. I had to multiply out here. I ended up, just to save you time to show you what I got, over n squared, and I started L'Hopital the piss out of it. I just went, okay, L'Hopital the first time would give me 12n plus 10 over 2n. If I L'Hopital it again, I'd get 12 over 2. That gives me 6. The answer was B, which was 6. I did not do that the first time. I did miss this one. All right, let's look at the calculator. We got 20 minutes left. 76 was not, you didn't even need your calculator for 76. It gave you the function. It asked about the derivative. That was really nice. It's just asking me about slope. That's it. So you've got a 0 slope, a negative slope, and a positive slope, and you're going from least to greatest, so it's D. D has f of at 3, you're a negative slope. At 0, you're 0 slope. And at negative 2, you're a positive slope. So 77, again, I don't have my calculator with me, and I'm sorry, but I will tell you what I plugged in because I tried to make notes so that you would know. 77 was tough because, did y'all get 77? Like, I know you got 77. You got all those first ones. H of x, and maybe you can tell us what you did that's different than what I did because I made it hard. You use your calculator too. If h of x is the antiderivative of all of this, so I wrote this on mine. If h of x is this is the derivative of h. And it says h of 5 is pi, then what is h of 2? I said, well, that means the integral from 2 to 5 and of the derivative has to be, and I use that fundamental theorem here. The integral and the derivative cancel each other out. So if I go from 5 to 2, so and this is straight up fundamental theorem, that's all it was. H of 5 is pi. H of 2 I'm trying to find. And then I used the calculator to find this. They gave me this equation. So I plugged this into y1 and I did the integral from 2 to 5. I didn't even write down what I got there. I must have been frustrated with this problem. But whatever you get here, you just subtract pi from it on your calculator. And you end up with b, which is negative 5.867. So that one was kind of tough. The continuous function f is positive and has domain bigger than 0. The asymptotes of the graph are x equals 0. So this was just testing your definition of asymptotes. Remember, as you approach, if you approach a number and you get infinity or negative infinity, or go towards a number, that's a horizontal asymptote. And if you approach infinity and you get a number, that's a vertical asymptote. So I kind of sketched over here, but it had to be C because as you go to 0, it's approaching infinity. That's a vertical asymptote at 0. And as you approach infinity, you get 2. That's a horizontal asymptote at 2. Just had to kind of think through that one. That was C. 79 was just testing you on units. That's all it was do you understand what's happening, what the units are, and what it means in context of the problem. Again, we still are not using a calculator on this one, which is crazy because it's in the calculator section. But for this one, it gives you, it says f of t is measured in megabits per second. So it's asking you about the derivative. It's the derivative of the derivative, which is the rate of the rate. So it's telling you it's got to be b because it's telling you that the rate is increasing or decreasing at a rate of. So it's the rate of a rate, I know. Number 80. Function has a first derivative, so you're finding the second derivative. I used my calculator on this, and let me tell you how I used my calculator on this. I found the second derivative by hand because it was an easy second derivative to find. I graphed this on my calculator. Okay. And when I graphed it, I looked at the zeros of the second derivative, which were negative 1 and 2, and I said, okay, it's below the x-axis, above the x-axis, which means concave down, concave up. So what intervals is it concave up only? And I'm just looking for where it's above the x-axis. Too fast, y'all, okay? 81, the graph of the function f is shown between negative 2 and 2. Which of the following could be the graph of an antiderivative? So I get, y'all know I get confused. I'm spastic. I wrote this is the derivative because it was confusing me on what it was that I was looking at. I did a little sign analysis over here, but this was kind of an easy one if you realized that what you were looking at was the derivative. If all you did was look at each of these graphs and said which one would the derivative give me up here, you could do that as well, but you'd find that it was D. I can't have all these humps in here, and this is the derivative up here, so it was D there. You did your little increasing and decreasing for that one. $82 gave you velocity but asked you for speed. Is that what it said? No, total distance. How do you find total distance traveled? Somebody said it. Absolute value. So for this one, it was the absolute value of velocity from 0 to 2. Again, straight on your calculator. Really? I wonder why it didn't work. I got 0.261, 2.261 whenever I did it. That's interesting. That didn't work. Huh. So you split it into two intervals. You took the negative interval. So whichever way you want, but make sure you're using the calculator on those problems. 83, you've got a derivative there. It says at what value does f attain a relative maximum? So if I've got the derivative, again, I put this straight on my calculator. I want to know where the derivative equals 0. When I put it on the calculator, I found that it was negative 0.591 and it was 0.638. This was negative, this was positive. I didn't even look at this last interval because it said, where does it attain a maximum? I knew it was increasing here. I just went with 0.638. I must have got bogged down on one of these because I was rushing through some already. Yes, no, maybe so. All right. 84, the number of bacteria in a container increases at the rate of there are 1,000 at time 0, which of the following gives the number of bacteria in the container at times 3. So if R of t is the rate, then if I want to go backwards and just find the number, I just have to do the integral. But this one tests too, and make sure you add in that initial amount. So it's 1,000 plus the integral, so we're going backwards. So just make sure you understand that. If they give you a rate and you want to know the amount, then you're going to integrate. If they give you an amount and you want the rate, derivative. 85 was testing you for the definition of the mean value theorem straight up. It was continuous, gave you two values, which of the following will guarantee that there's a C, and so then it gave you these pieces of the definition in a little bit different ways. It has to be differentiable in order for the derivative to equal that somewhere. If it's not differentiable, then it doesn't count. So it was B, but it was differentiable. It doesn't matter if it's increasing or maximum or any of that. The differentiability is the piece that matters. 86, I graphed every one of those. It's a twice differentiable function. Which of the following have exactly 2 points of inflection? I graphed F, I graphed G, and I graphed H. Remember, I'm looking for where the sign changes. And so on mine, I literally have this. I graphed F double prime. I didn't find the points. I don't care about the points. I just want to know the number of times it changes. This F goes positive, negative, positive, positive. So it had 2 points of inflation. G, positive, negative, positive, had 2 points of inflation. H went positive, negative, positive, negative, positive. It had too many. I eliminated that, so it was just F and G. But those were just graphing them, straight up graphing them. 87. Table above gives values of a function f selected values of x, twice differentiable in the interval. Which of the following statements could be true? So I underline could because that doesn't mean that it's always true. It just means there's a possibility of it being true. So what I'm doing is I'm eliminating everything that absolutely could not be true. So I went through and I looked at the difference. These are going down. They're definitely going down, but they're not going down by the same amount each time. These are equal increments up top, but the first one's going down by 5, then 4, then 3, then 2. So it's decreasing at a slower rate as I go. So I chose, let's see, the derivative is negative. It's definitely always negative. And increasing because those numbers are getting, I said decreasing, but they're actually getting bigger because it goes from -5 to -4 to -3 to negative. So it's definitely getting bigger as I go, but it's always negative, and so I chose C. Does that make sense? I'm talking a whole lot, and I'm tired of talking. F is defined, and I have this nice logarithmic function, and G is defined by this quintic polynomial. The line tangent to the graph of f at x equals 2 is parallel. There's your key because parallel means what? Same slope. That's exactly right. So here's what I did. I found the derivative of f. I got 1 over x squared plus 1 times 2x. And then I found the derivative of g, which was 5x to the 4th plus 3x squared. This is the slope of f. This is the slope of g. And so what I did was I found their points of intersection. So I could find, say, parallel to the line tangent to the graph of g. So I found where they intersected, which I think was, what was it, 2? I can't tell. I was just scribbling stuff at this point. I wish I had my calculator. But if you found that here, I could say that the derivative at a, because it said it's at a, right, is 5a to the 4th plus 3a squared. What did I do? I said they intersect at 0.447. So I must have found that point and plugged it back in. But that's what you're looking for, though, is the intersection of those 2 points and that x value. All right. Uh-oh, I starred 89. I must have missed that one. F be a continuous function for all real numbers defined by average rate of change is 6. Which of the following statements must be true? I didn't go back and work this one, I'm sorry. I've got notes. Did y'all get this one right? Anybody get this one right? Nobody got 89 right? No? Okay. I'll work that one out and look at it for you. I meant to go back. 90, for any function f, which of the following statements must be true? F is defined at x equals a, then the limit, that's not true, because just because you're defined at a point doesn't mean that the limit is the same thing as that point. Think about a hole. Think about as I go like this, and I'm defined here. This is the function value. This is the limit. They're not the same. 2 says if f is continuous at x equals a, then the limit is x approaches. That is true, because if it's continuous, there's no discontinuity, so it's just continuing on. And if it's differentiable, then the limit, and that's true as well, because differentiability has to be continuous and defined there. So it's C, which is 2 and 3 only, and that takes us through the whole thing. I can't believe we got through it. I skipped